Hi there. So today we're just gonna talk about the length of the sparrow, or you can also call it the distance of the sparrow. And let's say we're given the radius r, and let's say we're given the value of height h, and let's say there's a coil like a spring that has a certain number of turns. In this diagram, you can see, I put about 4 turns, but it doesn't have to be 4. It could be just about any, number of turns. Okay, so now what we need to focus is we need to first see the distance, the length of the sparrow in the first turn. Okay, so first we have to look at the length of the sparrow in one turn. So as we know, one full turn is 2 pi r, r being the radius, and 2 pi is the formula, if something makes a full circle. Okay, so now we have the height. Well, in one turn, obviously, like in a sparrow, there's also going to be a height, and height is, let's say, given as h. So in this diagram, you can see that it's made of like one turn sparrow. And so now what we need to do is stretch out the sparrow and treat it as if it's a hypotenuse, d, let's call it. So h, the height doesn't change. The height's still going to be the same as it is, whereas the base is going to be 2 pi r. And so now we can use Pythagorean theorem to find d. Suppose we're given h and r, then we can most definitely find d. Now, let's say there's a certain number of turns. Of course, it's the case with many springs, coils, or a lot of these applications. There's obviously many turns. So let's say n is going to be the number of turns, and and this is kind of intuitive and a bit obvious. As the number of turns increase, height and the 2 pi r will proportionally increase with the number of turns. So we can write it as h times n, so that is height times number of turns, and we also have 2 pi r times n, 2 pi r times the number of turns. So if we're to stretch out the sparrow, we could treat it as hypotenuse. So in this formula, we're given, let's take d as the hypotenuse. So it's gonna be d equals square root of inside is gonna be a bracket hn square plus 2 pi r n bracket squared and equals, and you can factor out n squared within the square root, and eventually you can even take out n square outside of the square root and make it into n number of turns times square root of h height squared plus brackets of 2 pi r brackets square. So here, this, if you know what r is, what h is, if you're given, let's say, a certain definite number or value, you can most certainly find the length of the sparrow. And I know that in some cases, like I mean, it could be a particle that travels in a spiral, you know, pathway. So we can also call it, distance, like a spiral distance. And in the case of, let's say, a metallic spring, we can also find the mass of the spring if we know the density of the metal that the spring is made out of. And once we find the length of the spiral, and once we find within the spiral, if we know the radius, then we can also find, the mass of the spring, the coil, and all the other things we need.